Okay, so we're going to be starting this lesson called Digging It, which is 6.6. And it says, by today, you'll be able to locate points in a plane using coordinates based on horizontal and vertical movements or based on circles and angles, and then use degrees and radians to measure angles. And then, are there other ways to describe the location of a point in the plane other than just by giving its x and y axes? And then what proportionality relationships can I find between corresponding points and arc lengths of concentric circles? And how can I justify why these proportionality relationships exist? So, just a couple of things really quick. Concentric means circles that have the same center, hence the word concentric with the same center. Um, so let's get into this idea here. So it says Alice, Javier, and Veronica are responsible for preparing a recently discovered archaeological site. The people who used to inhabit this site built their city around a central tower. The first job of the planning team, however, is to mark the site using stakes so they can keep track of where each discovered the item was located. So where all the items were located, they want to know, and they're going to keep track of this. So Alice suggests that the team places stakes in a circle around the tower, with the distance between the markers on each circle being equal to the radius of the circle. Javier likes this idea, but says that by using this strategy, the number of markers they need would depend on how far away the circle is from the center of the tower. Do you agree or disagree with Javier's statement? So they're basically asking. So here's a picture. So if you look at that inner circle, the inner circle is saying like, look how long that circle is, right? Versus the outer circle is larger. So Javier thinks is saying, hey, but it depends on how many stakes we need. Will depend on how far the circle is from the center of the circle, the tower. Okay, and so if you think about this, um, she actually says, I forget her name, Alice. Alice suggests that they put markers a radius away from around the circle, right? So a radius away from the circle. And so we need to figure out what does that look like, right? So so if you kind of think about this, if you think of, well, so first of all, what do you think? Do you agree with Javier? And so the way I'll explain this to you is if I take a radius from the tower to, you know, the circle, that's a radius away. And then so um what Alice wants to do is she wants to place a stake here, and then if I could pick up that thing and then like kind of like lay it down, it would probably be, I don't know, somewhere here-ish. Like think about a tape measure and I'm pushing it all the way around. And then I push this all the way around and I get to maybe here. I don't know. And I push this all the way around and I get to maybe, I don't know. I feel like I'm missing. I think I went too far on this one. Let me see. So here maybe, and then maybe another one like here-ish. Oops. And then another one probably like right here. And then another one maybe like right here. Another one right here. And right here. I don't know. Something like this, right? So you would have about 6 and then a little bit more. And maybe these points are a little bit off, but that's okay. Right? So the same thing would go is if I took, this radius for the bigger circle, now using this as my radius, would I end up with the same number of stakes or a different number of stakes? So Javier is saying I would end up with a different number of stakes because of how far it is from the tower and it's a bigger circle. But one of the things he's neglecting is that it's a larger radius as well. So if you lay these down, it'll probably look something like this, right? And then you'll see this kind of pattern, and probably my points are a lot off, but that's okay. You're kind of getting the point that it actually would be the same number of points. And the reason why is because you're measuring the circumference. And so if you remember, the circumference is equal to 2 pi r, or pi times d. And that's exactly dependent on the radius. So again, what the circumference is, it's the length or distance around the circle, right? And so as you can see, that is dependent directly on your radius. The bigger the radius, the bigger the circumference, therefore the biggest the circle. And then the smaller the radius, the smaller the circumference, the smaller the radius. Okay, so keep that in mind. Number 3 says, after looking at the model, Veronica says they need to have some more stakes if they intend to be specific with the location of the artifacts. Since most archaeological sites use a grid to mark off sections, Veronica suggests evenly spacing out 12 stakes around the circle and using the coordinate grid to label the location of these stakes. The central tower is located on the origin, and the first of each set of 12 stakes on the inner circle is placed at the points at 12, 0 and 18, 0, respectively. Okay, hold on, let me see if they have this picture here. There you go. So this is what they're talking about, 12, 0 and 18, 0. Okay. So Alice also wants to make sure that they record the distance around the circle to each of the new stakes, these initial stakes. Your job is to determine the X and Y coordinates for each of the remaining stakes on the circle, as well as the arc length from the points 12, 0 or 18, 0, depending on which circle the stake is located. Keep track of the methods you use to find these values. So basically, they now want you to find where all the stakes are going to be located. Okay. Okay. So take a second, think about how you're going to solve this problem. And let's see. So I'm going to read it to you one more time just so that you are all on the same page. It says, your job is to determine the X and Y coordinates for each of the remaining stakes of this on the circle, as well as the arc length from the points 12, 0 or 18, 0, depending on which circle the stake is located. Keep track of your methods that you use to find these stakes. So again, your job is to find the location of each of these points. Okay, give me 1 second. Okay, so just so we're on the same page, I'm just going to, one key thing that you have to know is they're going to start with 12 stakes around each circle. So if they start off with 12 stakes around each circle, right? So clearly you're going to get some at the crossbars, right? Oops. So here, 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 and here. And then because you're dividing it, 12 into 4 sections, right? Then each one is going to be kind of like here. So because we're starting off with 12 stakes, we're basically dividing our 360-degree circle into 12 parts, right? So of course you're going to use the triangle trig to figure this out. So the very first one we will do together, and then I'm going to have you write in the rest of them. So I'm going to draw in this triangle. So here's my triangle off to the side. It's going to look like this. Your job is to label this triangle. So again, we always draw our triangle, we label our triangle, and then we could do sine, cosine, and tangent, and then check our signs, right? So the very first thing I want you to do is, what do we know about this triangle? And then this triangle is this guy right here, just so that we're all on the same page. We're on the inner circle. So you know that this right here would be 12. Is it feet? Are we doing 12 feet? I forgot. Uh-oh. meters. We're doing meters. So this is going to be 12 meters. And so I want to know the location of this. So I'm actually going to need my x comma y. I'm actually going to need my x comma y. So I'm going to need this opposite side and this adjacent side to do this. And now I just need to figure out what angle that is. And if you look at what angle that is, yes, you should have figured out that that's 360 degrees divided by 12 sections. So that's 30 degrees per section. Okay. And you're like, oh my gosh, Miss Johnson, this is my 30, 60, 90, which I love, love, love so much. Very good. So in case you don't, I label this side as X. This guy is 2X, and this is X root 3. Okay. All right. So then I'm just going to solve. So if 2X is 12, this implies that X equals to 6 meters. So this is 6 meters. And then, so this is 6 root 3 meters, which because they want actual locations, I would say that they probably do want decimal equivalents for that. So I think there's a table down here. So stake 1, the location is going to be that distance, that 0 ratio, the arc. Okay, so I'm going to write my answers down here, but I'm going to organize it over here. Okay, so then that's 6 comma, so this is the point right here. This point is going to be 6 root 3 comma 6 meters. And so I'm going to use a decimal approximation for that. So, okay, so what is 6? Let's see, do I have the square root? Okay, let's see, I don't have square root there. Let's see. Oh, it's right here. What am I doing? Haha. 6 square root 3, sorry. Okay, so that's 10.4. So let me put that guy away. This is 10.4. So there's my location, 10.4 comma 6. 10, oops. Right? Okay. So the distance along the circular path. Okay. So the way that we're going to calculate this is if we think about the whole circumference of this smaller circle, C equals to 2 pi radius, which is 2 pi times 12, right? Is the whole thing is 24 pi, which in this case, so let's calculate that. 24 pi is 75 point, we'll put 75.4. And we traveled 1/12 of this. Does that make sense? So because we traveled 1/12 of that, right? So that we traveled 2 pi of it, right? So we can just write 2 pi. Feels funny, right? But that's okay. And then the rotation of that arc is going to be, so we're going to measure that rotation in terms of like how much it is rotating in terms of the circular path, right? So we go 2 pi, ratio of arc length to radius. So the ratio of arc length, that's 2 pi, to the radius, which is 12. So this is the ratio. So this is the arc length, this is that, and so we're just going to divide and we get pi over 6, which is really important. So we're learning this thing called radians. You will get used to it. Right now you are super used to thinking in terms of degrees. So we're going to get used to thinking in radians. Radians is Radians. So again, one more time, how did I get this pi over 6? I took the ratio of 2 pi, which is from here, and we divided it by our radius, which is 12. And so we got pi over 6. Okay. I'm going to stop the video here. You're going to try filling out the rest of this, and then I'm going to come back and I'm going to show you a couple more just to make sure that you get it. Okay, so now that you're back, we're going to try a couple more of these and make sure that you are super comfortable with understanding this. So I'm going to try one on the outer circle and see if there's any kind of difference. So the location for 18, 0, I mean, not 18, 0, for the next number, for if the circle is the bigger circle, okay? So it would be here for our next circle. And again, we have the same number of stakes. And so we realize that this is going to be like here. So it's just a bigger version of this triangle. Can you guys all see how this is like, gosh, I wish I can draw better, but it's the same. If you think about this point on the 12 radius circle, it's on that radius of the 18 of that hypotenuse, right? Do you guys all see how that triangle? So what I'm trying to say is I can extend this out and then get that bigger triangle there. That's what I'm trying to say. So I want to see what the differences are between the 18 and the 18 radius circle, or the circle with the radius of 18 and the circle with the radius of 12, and see what it is. And so if you notice, this is going to be the same exact triangle, except our number one, our triangle is just a little bit larger. The 30 degrees is still going to be the same, right? Except here we have 18 meters, and now we're looking at the opposite and the adjacent the same way. And you're like, but Miss Shelton, this is still your 30, 60, 90. Exactly. So this is going to be our 2x. So that implies that x equals to 9 meters. So that's 9 meters here. And then this is going to be 9 root 3 meters. And then we would calculate that to get a more exact number. Let's go Desmos. And what is 9 square root of 3? And it's about 15.5. So this point here is about 15.6, or let's go 15.59, comma 9. Okay. Let's see if we see any trends there. So 15.59 comma 6. Not 6, sorry, comma 9. Sorry, I was looking at that other thing. Now I'm erasing. There it goes. 50, comma 9. There you go. And again, that distance along that circular path is still going to be, if you think about it, we got to figure out our circumference for this, right? So our circumference, I'm just going to write it on top here so you guys can all see our circumference. Where did we put it? Over there. It's 24 pi. So this one has a circumference of 24 pi. And then, so this one is the circumference of 2 pi r, which in this case, our radius is 18. So it's 2 pi times 18. So C equals to 36 pi. Now, if I take 36 and I divide it into those, remember, we're dividing it into our 12 sections. So this right here is going to take 3 pi of that. That's how long it is to travel. Okay, does that make sense? So I took, and maybe I'll write my calculation here. It's 36 pi divided by 12 sections. That means it traveled 3 pi along that path. Okay, so like, can you think about 3 pi as like the distance that you ran? Like, hey, how far did you run? And someone goes, oh, I ran through pi, right? 3 pi seems like the answer wouldn't make sense, but they're just indicating to you they were running along a circular path. But even when people run along a circular path, like if you look at like, the, track or whatever, they don't tell you that it's pi because they don't need to. They take that distance and they make it a linear distance, right? So the ratio of that arc is going to be, let's see, it's going to be just like we did over here, right? So we're going to do this over here. So we take our 3 pi and we divide it by our 12 sections. So that's going to give us pi over, it's 18, sorry. We're going to divide it in because it's our radius. We're going for the arc length to our radius. So this is arc length here. This is our radius. I'm just following the directions that it says, right? It says, I want the ratio of arc length to radius. So they're just telling you to write a fraction where the numerator is arc length and your denominator is radius. So if I divide that out, that becomes pi over 3. Okay. And I think I'll do like maybe a couple more just so that you're a little bit more comfortable with this. So why don't you take a second, and I'm going to do the very next I'm going to do the very next one for both of them. I'm going to do these ones. I'm going to do both of those triangles. Okay. So if you can, number 1, draw the triangle, label your triangle, and then start filling in your points, your distance along the path, and then the ratio of arc length to radius. Okay. So just kind of follow my steps. It's going to feel a little funny that the ratio of arc length to radius is going to make sense in a second. I promise. But I want you all to practice this because this is this is like one of those big deals. Okay. So go ahead and pause it and see if it makes sense. And then come back to me and I'm going to do number 2. And because you guys know about symmetry, because I did the first quadrant, you can almost like flip everybody to figure out all of the rest of them. Okay. So I'm really going to focus on this first quadrant. I'm going to build it all out. And then we're going to talk about the symmetry of figuring out the rest of them. Okay. All right. So go ahead and go get that done. All right. So now that you're back, I'm going to do more of this triangle stuff. So I am going to do those next 2 ones. And so maybe I'll draw it in this color. And so the next one looks like this. If you can kind of like see this triangle, do you guys all see that? So it looks like this. So there I've drawn my triangle, and I'm kind of trying to look at both of them at the same time. So you know that this is 12 meters, and you're like, wait, if this is 30, what is this angle in here, right? And you're like, oh, it's 230, so this is 60, and you're still excited because, oh, Miss Johnson, this is still my 30, 60, 90 triangle. Very good. So now, and if you think about it, it's exactly this triangle up here, except like rotated, right? So again, this is going to be your x, this is 2x, and this is x root 3. So I could have just copied that same triangle and rotated, but I like doing this over and over again so you guys can see it. So that implies x equals to 6 meters. And this is 6 root 3 meters. And I'm going to copy that number, which is 10.4. So this number here is going to be 6 comma 10 point, what did I say, 4? 6 comma 10.4. And you're like, hey, those two numbers just flip-flopped. Pretty interesting, right? So yes, actually. So then I'm going to take that and I'm going to go 6 comma 10.4. So now how long did you travel? So I want you to pretend whenever for this one right here, the distance, the second column right here, it says distance from 12, 0 along the circular path. Can you pretend that you're a tiny little ant? Okay, you're a tiny little ant and you're traveling. Let me go in yellow or something so you can see what I'm talking about. So you're traveling, and you're saying, okay, how far did I walk along that yellow circular path? Right? And so the way you figure it out is, well, so this is again the circuit. Maybe I'll do circular path on this side. So this is distance. So since distance from 12, 0, the way you're calculating this is you're taking your circumference, right? And you're dividing it by however many pieces you have, right? So this one, if you notice, we have two of those pieces. You already know one of them is in this case 2 pi. So you're hoping that two of them would be 4 pi, which it is. So we took our circumference and we divided it by 12. So in this case, we got 24 pi divided by 12, which equals to 2 pi. So this represents how much distance for each section. So this is distance per section, right? Since we're covering two sections, wouldn't it make sense that this would be 4 pi? Doesn't that make sense? Right? Doesn't that make sense? Yes, that makes sense, right? Okay, so then this part here, this ratio of arc length. So maybe I draw arrows so that you guys can follow where I'm going here. So this right here, this column right here goes here. And then this column right here is just kind of like this math over here. Right? So that's what we do over there. So we're going to do the same thing. So this time it's going to be 4 pi divided by 12, which is pi over 3. Which, oh, that's cool, Miss Johnson, because look, that's pi over 3 right there. Right? Miss Johnson, look, these two are both pi over 3. Yeah. Pretty interesting, right? So there, you're going to notice some similarities there that we'll highlight every now and then. Okay. So one of the patterns that you guys said is you notice that these two numbers right here, they flip-flopped. And that should make sense to you, right? Because our triangle kind of flip-flopped, right? Earlier, the opposite was the 6, and now the opposite, well, let me see. The opposite was 6, and now the adjacent is 6. So do you see how there's like lots of flip-flop? I don't necessarily know if I do actually know if that's a thing that I want you to stand on, but for sure you'd be able to figure it out using this other triangle, right? From the 18. So I'm going to draw this triangle in here and see if it's the same. So here's Miss Johnson trying to draw this triangle. And then you guys all know that this is 18 meters this time. And then this is our 2x side. So x equals to 9 meters, which this is, again, 60 degrees. So this is our 9 meters. And this is 9 root 3, which we already know 9 root 3 was 15.59. So our x going this way, this is our x. In case you don't know how I'm getting this x number, it's this distance here, right? So this is 9, comma. And this number here, this is our y to get to that point, right? That's exactly what we described. So we said it was 15.59. And yeah, they did flip-flop places, right? So yeah, so we're going to write that down as 9, comma 15.59. And then we're going to do that same calculation. We're going to go 36 divided by 12, but this time we're multiplying by 2 because we have 2 sections. So 36 pi divided by 12 is 3 pi times 2. Yeah, this is 6 pi, right? And according to this, you just told me to do the ratio of 6 pi divided by 18, because that 18 is our radius, and this becomes pi over, did I do that wrong? I feel like I did something wrong. Oh, I did do that wrong. This is pi over 3. This one I multiplied wrong, and this is pi over 6, y'all. I messed up. Yuck. So that needs to be fixed. So make sure you fix that last one. I don't know what I was thinking. I think I was going too fast. So this is 6. Miss Johnson makes mistakes. And I don't even have you guys all here to like help me out. Yeah. Okay. So that's pretty much it. And I'm going to repeat this process, and I'm going to hopefully show you back and forth and back that you guys are all able to see all of them. But the last one that I want to do, I do want to do the one that goes straight up for our 90-degree one. And this one's actually going to be pretty quick because you should remember that if I wanted to find this location here, well, it's 0 going right and left, and I just go straight up to the radius. So this one is going to be, let's see, 0, 12 for this one. And this one is going to be 0, 18. And if you do notice, there is some switching here and here. Do you guys all see that? Here and here. There is some flip-flopping again that you notice. So if this continues to make sense, you should be able to figure this out. We got 2 pi, we got 4 pi. What's the next number that we're actually going to write here? Yeah, you guys would say 6 pi or 3 sections, right? 3 sections of that. And then over here for 18, you can look at the pattern. Notice that it's going to be 9 pi, right? Okay, to figure out the arc length radius, I'm just going to continue on. So this is 6 pi. So I'm going over here. So I go 6 pi over 12, which is pi over 2. So this is pi over 2. And same thing goes here. This is going to be 9 pi over 18, which would be pi over 2. Oh man, Miss Johnson, those numbers match. And I'm like, exactly. Okay, so I'm going to show you one flip-flopping, and I just want you to figure out the rest of them. So what you should notice is that if we're continuing around this whole circle and we're going to go to this next target, which is right here, right? You should notice that this is a reflection of this. Can you see what I'm doing there? So this here is a reflection of this here, right? So really, it's just it's the same. If you notice here, these points here, it's going to have the same y. And how are the x's related? It's going to have the same y, but how are the x's related? So if you're thinking about this in terms of triangles, I'll draw the triangle here. This triangle looks like this, right? Where this is 60 degrees, right? Or this is, you guys figured this out too, that this is 120 degrees, which helps you greatly, right? And you know that this is 12 meters. So you'd be able to figure out that flip-flop triangle, right? So that triangle is exactly the reflection of this triangle over here. It's the reflection of that triangle over there, right? Okay. So then I would say, okay, well then this is negative 6 meters. And then this is still 6 root 3. And this point again, so looking at this point, it goes left this way. So that's negative 6 comma. And it goes up let's see, it goes up this way, which I think that number, oh, it's 10.4. So Ms. Johnson, these numbers are just changing spots and signs. Yes, very good. So I'm going to copy that down. So you should be pretty comfortable with this. So -6, 10.4. And you're like, hey, Ms. Johnson, these two are related here and here. Yes. Right. And then you would just continue your pattern. 1 piece of pie, 2 pieces of pie, 3 pieces of pie. Like, how much is it now traveling? So 2 pi, 4 pi, 6 pi. This is 8 pi. Oops, I'm not writing. So 8 pi. And if I do that calculation, and I've been doing them over here, so I will follow suit. This is 8 pi over 12. Okay, so let's see. That means I have to simplify. So that's 2 pi over 3. That's 2 pi over 3. So that means that's 2 pi over 3 here. Oh, that's interesting because that's the guy that matches, right? You were saying that guy matches that guy. Yeah. So here's what I want you to do. I want you to let's see. I want you to invert, revert, like change, reflect, or actually do these all by hand, however you want. And then come back and I will show you all the answers. It does you no good for you to just copy all these answers. It doesn't help you. What really helps is if you go through these and make sense of every single one. So I'm probably going to do like one more of these. I'm not going to do 18s because now you saw that. Let me pick one that I would think would make sense for us to do. Yeah. So let's say that I was going to do like this one right here. Oh, let's go this color. Let's say that I was going to do this color right here, or this stake right here. You guys all see this? Who is this guy going to be related to? Yeah, he's actually going to be related to a lot of them. But this guy right here is really just a reflection of the pink guy right above him. Do you see the pink guy right above him? Sorry, I can't draw very well, but do you guys all see how those are reflections of each other? Except for he goes down, right? So it's almost like I want to do this guy right here and reflect him down, right? Oops, that arrow's so big I can't draw. So I want like him to be a reflection. So it's almost like I want him to go like this, right? So they're supposed to be the same size, just reflected down, right? So then again, of course, this is going to be 18 meters. This is 30 degrees. But now instead of this opposite being 9, it's going to be -9 because you're going, right? You went down this way. But my adjacent's going to be exactly the same at 9√3 because you're going to the right. So this point is going to be 9√3, which is 15.59, comma -9, right? Look and compare between this guy and this guy. Because this guy, again, right, that it's these 2 points we're talking about. They went in the same x direction, but then when they got to that 15.59, the y for one of them went up and the y for one of them went down. So let's do that one. Let's see. What would that be? That would be our 11th stake, right? So that would be, let's see. What did I say? It was at 15. Yeah, it was 15. It was 15.59, comma -9. Right? Okay, so how many pies would that be? Well, if you count them, it would be 3, 6, 9, 12, 15, 18, 21, 24. Oh, you can't see what I'm counting. Sorry. 18, So this would be 18 pi, right? All the way through. So then that's 21. Wait, did I see? I'm not counting right. Hold on a second, guys. I'm trying to go back. So this would be 12 pi and so on, right? So this would be 15 pi, 18 pi, 21 pi, 24 pi, 27 pi, 30 pi. So I think this would be 36 pi, which I'll tell you right now it is. Okay. And later on, it'll make a lot of sense of why it's 36 pi. And then you would do it, right? You would go 36 pi divided by 18. And you're like, how do I simplify that? Well, both of them have sixes. So that's, did I put 36 pi? Let's see. I think I counted wrong. I think it should have been 33. Hold on. 3, 6, 9, 12. Yeah, because it has to be 33. Because this is, right? That's 33 pi. Okay, my bad. 12, 15, 18, 21, 24. Oh, I just skipped 33. My goodness, Miss Johnson. Okay, so this is going to be 33 pi. So this is going to be 33 pi. And what do they both have in it? They both have 11. Or 3, sorry. So this is going to be 11 pi over 6, which that's exactly what it is. Okay. So you're going to fill all this out. You're going to see, and I'll write the answers here just so that you can check it and check back and make sure that they're all good. That way you guys can all see it. Okay. I'm going to put the answers at the very end just so that you don't get distracted by those answers. Okay. So this is the last question that we're going to go over, and then we're going to go over the takeaways, and then I'll post the answers. It says, what patterns might Alice, Javier, Veronica notice in their work and their table? Now, look, you should find a bunch of patterns here. You should find a bunch of even in the like we only did like a fourth of it, really, maybe a little bit more than a fourth of it. You should be able to see all of those patterns. Okay. Patterns like, hey, Miss Johnson, across, there's a lot of like stuff that matches across, right? And then picking and choosing like the 2 green ones that we highlighted, those are more patterns. Okay. So let's go over our takeaways and then we'll be done. All right. So our takeaways. So angles can be measured in radians. Okay. So in case you don't know, this column right here, these are our radians. This is a really important column right here. I don't know. I'm going to put it in this dark blue. This column here is our radians. What does that mean, Miss Johnson? So instead of calling 30 degrees, I can now call it pi over 6. Johnson, why do you want 2 different sets of numbers that describe the same thing? Because pretty cool things happen when we talk about things in radians as opposed to degrees. Because then I don't have to keep track of 1,274 degrees, because now I'm just keeping track of whole pies, or 2 pies in this case. Okay. So yes, we can. So the radian measure of an angle is the ratio of the arc length of the circle to the radius. So this is the ratio of, and then I'll write it as a ratio, arc length divided by radius. Okay. So for example, for that one we showed you, we noticed that the arc length was, 2 pi, and we divided it by 12. So that was pi over 6. In my brain, when I see pi over 6, my brain says, oh, that's 30 degrees. How come, Miss Johnson? Because if you take 2 pi, which is a whole, that was the radius. Actually, no, I won't say it like that. I'll be quiet. I'll just wait for you guys to see it. Okay. So, and then we can locate points in the plane by providing 2 different types of coordinates. Rectangular coordinates is what you're used to. It's a x comma y. Okay. And then there's polar coordinates, which is what we learned today, which is a radius comma theta. Now, this is formalized now, like we have a radius comma theta. So that means, like when we were going back here, right? Let's go back here. I can talk about any point I want on this circle, on this coordinate plane, by giving you an angle and the radius. So if I wanted to talk about this point right here, I can tell you the rectangular coordinates, which is some number like x comma y. Or I can say, well, this is also, and I can do this without even calculating, right? Because I know I need to know the radius. Okay, so the radius here is 12. So this point here, it's 12 comma, and then the angle. So what angle is that? Well, if this is 30 degrees and that whole thing's 180 degrees, so that angle is 180 plus 30 degrees, which is 210 degrees. I can also talk about this in radians. Now, here's how you would talk about it in radians. This is why I love radians. Okay. If I have to think about 210 degrees, I'm like, where are you? But if I talk to you in terms of, did I say that wrong? If I say degrees, I'm like, where are 210 degrees? Where are you? But if I talk to you in terms of radians, I know exactly which triangle I'm in. I know exactly which quadrant I'm in just because of that. Okay. So for example, because this is 30 degrees, I know that the denominator for 30 degrees is 6. You'll learn this too later. But I also know that this whole thing right here is a pi. This is 0 over here, and this is pi over here. So I have a whole pi, which is 6 pi over 6, and then I have an extra slice of pie. So how many slices do I have? I have 7 pies over 6. So we're going to play around with this more later, but this is an actual location. 12 being the radius, theta being whatever angle you are. So some of you are going to hold on to degrees and you're like, no, I love my degrees. I'm going to use them. I'm going to use them. And it's going to be a really hard transition for you to move over to radians. I will say in the next unit, it'll help you if you transition to radians. Okay. Going back to our takeaways. Let's see. Oh, wait, where's my takeaways? There it is. So you are going to be able to practice your polar coordinates here. Let me show you here. Let me see. Sorry. Wait, let's write this here. Sorry. Yikes. There, it was right there. Oh, I'll leave you to it. I want you to practice this. So it says select a word, short ones are best, and assign numbers to it. Yeah. Try this. Okay. Let me show you your exit ticket as well. Your exit ticket is over here. Sorry, we're scrolling. It says using the coordinate grid, locate a point located at 3, 4. Explain another way the point's location can be described. So they're asking you to describe it using polar coordinates. Again, polar coordinates are r comma theta. R comma theta. Okay.